here we have a Medi tester, and we still use it for some things, as you can see. This guy here had an electrical issue. As you can see, my previous connectors that were replaced, you have to strip back the wires far enough that you get past the rigid copper conductor, because that's where the heat damage is, and here on it was actually good conductor. So those points were changed. You can see in there that I also heat shrinked over them. But now, what caused that? This is caused by overcurrent. So it's either overcurrent because of components, or it's overcurrent because of too thin a conductor. Hard to say, but we can test that. And we test it with our electrical safety analyzer. Is one of the easiest ways to do it. Just connect your device, put it on equipment current, and then we are going to run the device. Currently, you can see it flip-flopping right here. This is caused by the heating circuit, because it is a heated water bath. That it's kicking on the heating element on and off, on and off. We can go ahead and turn on the agitators and the lift motors, because we got to test everything and see how much current this guy's really drawing under max load. So let's go ahead and start the agitators. Let's see, add time. Okay. Here's the agitators running. The heating element is running. And what we can do is we can monitor the amperage against the data plate for this guy. Alright? So this guy's set for 15 amps. I think the data plate is set for 10.5, 11 amps. It did not trip the breaker, and yet it did have an overheat. So you can see we're running the agitators. They're drawing almost nothing. That's good. That means that both those motors are good. We just had these motors raise up, and neither one of those motors were bad. And for you prompt users, you can also monitor equipment current by going into manual mode. And you can see here I've got manual mode selected. We're going to hit enter, and you go down to leakage, normal, polarity, enter, enter. You can see it's going to show you your leakage, and right here is your amperage. So watch this. Okay. All right, and cycle will start. Okay, here we go. You can see it's showing 9.6 amps, 9.3. Let's go ahead and turn on our agitators, so we can monitor leakage and amperage all on one screen. Kind of cool, because if you got a defective motor, often it will induce leakage. And you can see it fluctuating right there as it turns the heating element on and off. So that's how you use electrical safety analyzer to help you figure out a problem. We run one motor at a time. If there was an overcurrent condition, run one motor and then monitor it, and then run the next motor, then the next, then the next, and until you limit it down to whichever unit is giving you problems, and the only thing left is the heating element. So the way to test the heating element is you either pour some cold water in it because it monitors its temperature, or you let it cool down naturally and then you turn the device on. Meanwhile, you watch this guy and see what it ramps up to. I've had to do that once before for this guy for a different unit, but it kept popping the 15 amp breaker. So I finally set up my electrical safety analyzer for that one, and I monitored it, and it popped it off at 10 amps. So that was a bad breaker. But guys, that is electrical safety analyzer as a troubleshooting tool to try and find an overcurrent condition, which I think this guy is finally resolved. Anyway guys, that's all I got for you. Something simple. Maybe you didn't know that you could do that with your safety analyzer, but you can. So thanks for watching.